Hello and welcome back to my favorite people. As usual, thank you very much for watching this lecture video. And in this lecture, we're going to go through ring opening reactions of epoxide. And for sure, we know one thing about epoxide, that epoxide ring is under strain. And because the bond angle is around 60, and we know carbon, it has sp3 hybridization. So that means the bond angle is supposed to be 109 instead of 60. And so we can say this, that ring opening reactions for epoxide thermodynamically is favored because we're going to get 109 for carbon, bond angle of carbon, it will turn to 109, and which is going to be really, really stable. Now, how can we, open that ring? We can run it under acidic or basic condition. And for example, when it comes to Grignard reagent, it will add R to the ring, and other side we will have alcohol. So we will get R. When with negative charge, it will be added technically to the ring. Alcohol, they will add R O to the ring, so we will get ether technically, and alcohol. And the next one is going to be the hydride reagent, say, for example, sodium borhydride or lithium aluminum hydride, and they will add H minus to the ring. So one side we will have saturated technically carbon, other side we will get alcohol. And the alkoxide, they will add RO to the ring, and this one will come with a negative charge. So similar to alcohol, we will get ether plus alcohol. Okay. So as you see, if we add the strong nucleophile is going to attack the ring. And so in this case, we have primary carbon on both sides. There is no preference here. The reaction is going to be SN2 reaction. So this one is going to be SN2. And because it's a SN2 and there is no preference, there is no much difference in, there is no technically difference in steric effect here. We can attack either carbon, and we will get technically an OH plus and alkoxide. The alkoxide, very soon it will be neutralized by acidic H from protic solvent like water. So at the end of the reaction, in order to quench technically or stop the reaction and get the final product, always we need to have acidic H. So we're going to use either water or say ethanol, like an alcohol at the end, to give it acidic H and technically get alcohol. Okay. Now, I said we can use different reagents, and depends what we are using. Always we get alcohol plus whatever the nucleophile is going to show up on the other side. So one side we're going to have alcohol. I'm going to show that one. So always we will get alcohol. Okay, no doubt about that one. It depends to our nucleophile. Okay, so it depends to what's the nucleophile. Nucleophile is going to show up here, and I'm going to highlight it with different color. This is going to be the nucleophile. Okay. Now, if you're using alkoxide, they will add RO with a negative charge. If we are using, let's say, salt of sodium cyanide, the cyanide with a negative charge, it will be added to the system. And this one, it will add SH with a negative charge. Again, those are strong nucleophile. The Grignard reagent, it will add R minus to the system, and lithium aluminum hydride, that one it will add H minus to the system. Okay, and so as you see, it depends. Depends what nucleophile is. We get different products. So epoxide are really good, actually, precursor compounds to get different, organic products. We say the ring opening is regioselective. What does it mean? Okay, and it means because the second, the ring opening is the SN2 reactions. The SN2 reactions, the SN2 attack will happen on a carbon with less, okay, with a carbon with less steric effect, okay. That means the OH or the alcohol, it will show up on a carbon with more substituent. always we get this one. OH will show up on a carbon with more substituent. In this case, this example is we can differentiate them because we have the same order for the carbons. But let's practice some carbons, some example that they have different order of carbons. Okay, so when it comes to radioselectivity, and I have one carbon here that is a tertiary carbon, and this one is a primary carbon, and reaction is going to be in ring opening. I need to have a nucleophile. Say we decided to use, for example, RO, okay, or this. So we use this one. Sodium will have a positive charge. This one will have a negative charge. Sodium methoxide, and this one, the methoxide, it will be the nucleophile. So the attack will happen on a carbon with less substituent, and because it's a SN2 reaction, so the product that we get, we will have OH here, and then we will have methyl and methyl. Okay, and then this one we have two hydrogen, already have two hydrogen there, and we will have the R O, or we can say OR there. Okay, and clearly the first step is not going to be alcohol. The first step is going to be technically this compound, and that it has a negative charge, and but this one is going to absorb, it's going to absorb one H from the solvent technically, and it will turn to alcohol. Okay, so if we give it an H, and okay, this here we take H from solvent like water, and now we will have H there, and we get then alcohol. Okay, and forgive me, I need to say this one is methyl, it's not hydrogen. So I have CH3 here, CH3. Okay, so as you see, the alcohol showed up on a carbon with more substituent, and because the attack always is going to happen on a carbon with less substituent. Okay, and another example, okay, we have a carbon that's this one, the one on the left is going to be a secondary carbon. Well, this one is a primary carbon, and our nucleophile, it will be the SH. So the nucleophile, it will be the SH with a negative charge. And so what do we get? And if this one happen, we will get such a product. We will have SH here, and we do have two hydrogens there. So there is no stereocenter here. And but other side, we will have the O here. That's going to be OH after absorbing H, or taking H from the solvent, it will turn to OH, and then the methyl, it will be pointing down here to us, and then hydrogen, it will be there. Okay, now the attack happen on a carbon that is not a stereocenter. Okay, and so I'm going to say the nucleophile, the SH, or the nucleophile attack this carbon. And because that's not the stereocenter, it did not change the configuration. Okay, let's prove it. And here we have this one is 1, and then this is 2, and that one 3. And now what's the configuration for this one? This is going to be R configuration. Let's check this one. This is 1, 2, and 3. Again, the rotation, it will be clockwise. So this is R configuration. Okay, because we attacked a carbon with less substituent, and that carbon, it has only 2 hydrogens, and they were identical. So we did not actually have a stereocenter. This here, the configuration of the left carbon did not change. Okay, now, and when it comes to stereoselectivity, okay, so the first one we said we have a radioselectivity. Attack always will happen on a carbon with less substituent. The alcohol, it will show up on a carbon with more substituent. Okay, always this one is going to happen. Now, what's the stereoselectivity? Let's assign the configuration of the starting compound, and the configuration of this one, it will be, okay, go 1, 2, 3. This is going to be R, and here we have, say, this one is going to be 1. And number 2, it will be here. Okay, and this one, it will be number 3. So that's going to be S configuration. So this is going to be S configuration. We have R and S. Remember, hydrogen is here. Okay, again, this is 1, that's going to be 2, and this one 3, and hydrogen is number 4. So it will be counterclockwise, and this is going to be S. Okay, now, if, for example, use, let's say your nucleophile is, say, either a bromide or let's say SH, it doesn't matter really what's the nucleophile. I'm going to go again with the SH as a nucleophile and see what will happen if we add this one to the system. And in that case, we will get this one as a product. Okay, so we have, I'm going to zoom here. We have one carbon that is a tertiary carbon. This one is a tertiary carbon, while this one is a secondary carbon. And the attack will happen on the secondary carbon, and that's going to change the configuration of the secondary carbon. That means hydrogen, it will show up, and it will be facing to us. So I'm going to put hydrogen here, and this is going to be hydrogen. And so hydrogen is there. And now what will happen to the O, it will show up there. This is going to be the OH. Now, remember that we do have a methyl. This is methyl. And the nucleophile was added to the bottom of the molecule, and then to the end of the molecule, from the bottom of the molecule was added. So if you add it at the bottom of the molecule, then you will technically add the SH here. Maybe I should draw this one in this position just to make it more clear. So I'm going to add hydrogen here. This is going to be hydrogen. Now let's assign the configuration of each one. Okay, the tertiary carbon is not going to change. The reason for it, the O used to be on the top, now still is on the top. So this is going to be our configuration. Okay, and the proof for it, we have 1. Okay, and this is going to be 2. That one 3, and this is 4. So this is a clockwise in our configuration. Next, we have here we have 1. That's going to be 2. And 3, it will be here. So this one, it will be counterclockwise, supposed to be S, but hydrogen is facing to us. So because it says S, I'm going to flip it to R. Okay, so now we got our configuration for this center. Okay, remember, we used to have R and S. Okay, R and S for the starting compound. So this one used to be R and S. Now we turn it to R and R configuration. One of the stereocenter did not flip, okay? And this one stayed as it is. Okay, the second one flipped. Okay, now the one that flip is the secondary carbon, okay? The secondary carbon, and got flipped from S turned to R. And what's the reason behind it? Because this is a SN2 reaction, and in SN2 reaction, always the configuration is going to flip. Okay, and so it depends what you start with. You will get opposite of it as a as a product, as a configuration of the product. Always is going to happen. And if you start with S, you get R, or if you start with R, you get S. So we say we have a stereo selectivity here because we have inversion with the configuration. Always that's going to happen because the second step is the SN2 reaction. Now, okay. And the second part, it will be the ring opening under acidic condition, and I'm going to keep this one for next lecture, and I will pause the video here, and I will see you very soon. And thank you very much.